Hello, statisticians. Mr. Youngsaver here from Skew the Script. Today we're going to be talking about some controversial claims about racial differences in IQ. We're going to analyze that data. To do so, we're going to look at normal curves as well as the empirical rule. Let's skew it. Today's lesson is about normal curves and the empirical rule. This is Unit 2, Lesson 3 in our sequence. Today we're going to talk about a controversial book that was published in 1994 called The Bell Curve. Among the controversial claims in the book, there was a claim that different races showed different average IQ scores, and that represented a difference in intelligence. So we're going to talk about that data specifically and challenge it. And in today's key analysis is going to be about, are there actually true racial differences in IQ, in quote-unquote intelligence? So let's get into it. If you want to follow along using our guided notes, please go to our website at that URL. Now, let's talk about first, what's a normal curve? A normal curve is a symmetric set of data that is quote-unquote bell-shaped. The mean at a normal curve equals the median because both are located in the dead center and both are equal. The most of the data points in a distribution are close to the center. As you can see here, the bulk of the data in this bell shape is close to that central data value. So most people believe that IQ, a measure of intelligence, follows a normal curve. IQ stands for intelligent quotient. And it's a single number summary of your supposed intelligence. It's widely believed to be normally distributed. The most often cited mean of IQ is 100 points, and the standard deviation is about 15 points. There are different tests that have different measurements. This is an often cited one though. So we can look at that and visualize it here. Let's talk about the empirical rule, a way to analyze a normal curve of IQ. So the empirical rule states that within one standard deviation of the mean, so within, in this case, 15 IQ points on either side of the mean of 100, we have 68% of our data. So the majority of our data is already within one standard deviation, one typical unit of distance from the mean on either side. Within two standard deviations of the data, so in this case, 30 on each side, 2 times 15, we have 95% of the data. And then within 3 standard deviations, we have the vast majority of the data. 99.7% of the data is within 3 standard deviations of the mean. This is why the empirical rule is often referred to as the 68, 95, 99.7 rule. Now you see this, it's very, it's even more impressive to go back to our 2.1 example and see all these 3 grades in the MBA were mostly almost at 3 or above 3 standard deviations above the mean in point scoring for their eras. So you can see they are way above the vast majority of people in the league. So many standard deviations away, you get to be good. So let's look at an example with IQ in the empirical rule. Say you take an IQ test and get a score of 130. Assume IQ is normally distributed with a mean of 100 points, standard deviation 15. What percentile are you at? When you get a question like this and it has the word normally distributed in it, you need to do a few things. 1, draw and label a curve. Drawing the curve lays out the problem for you and makes sure that you're doing it accurately. Label it well, include the mean, the standard deviation, tick marks, and shade the area in question. Then perform your calculations, showing your work, and then answer the question using context. So in this case, we're wondering what percentile is a score of 130? Well, let's draw it. We've drawn the normal curve here, centered at 100, tick marks representing the standard deviation of 15, and we've shaded above 130, meaning that's the area we're not looking at, and we're looking at the percent that's below. Because remember, percentile is the percent of data that's below a certain value. So we're wondering what percent is in this area of our curve that's below 130. Well, that area, that value of 130 is 2 standard deviations above our mean. And we know that within 2 standard deviations of each side of the mean, we have 95% of our data. So we know that that missing area, we have 95% of the data plus 5% on either side, because that adds up to 100. So we can do 100 minus 95, and we know that 5% of the data is on either side. We can divide that 5% by 2 to get how much is on one side. So we have 2.5% in that lower tail. And then we add it to the 95 that was also included in the middle to get 2.5 plus 95% in that white area means that we are above 97.5% of the data. That's how you use the empirical rule to get a quick calculation out of a normal curve. So answering this question in context, that's step 3. An IQ score of 130 is at the 97.5th percentile of IQ scores. It's at that percentile. Let's look at another example. What score would you have to earn an IQ test to be at least the 84th percentile? So at least means you're at 84th percentile or higher. First things first, always draw. We need to be above 84% of the data. So we're wondering, how can we get above 84%? Where's that line at? We're wondering, here's my question mark. What value is that if I'm above 84% of the data? Well, we know that at the halfway point, we're above 50% of the data, so that helps us out. The remaining percent in 84% is 34. 50 plus 34 is 84%. So we need to find 34% above the middle. Where does that leave us? Well, remember that within one standard deviation of the mean, we have 68% of our data. So if we divide that by 2 to get just the amount one standard deviation above the mean, that's 34%. So that means that if we take the 50% and add the 34% above it, that means we have to go one standard deviation above, so 15 points above 100 in this case. So that means that we're at the 115 score. So you need a score of 115 points to be at the 84th percentile of IQ scores. So we know normal curve now, we know the empirical rule. Let's discuss one application of this. Different researchers have studied race and intelligence. In particular, there was one controversial book that came out in 1994. Many people believe that intelligence follows a normal distribution in terms of IQ. And this 1994 book called The Bell Curve makes the argument that this is exactly right, that intelligence can be measured in terms of IQ and that is normally distributed. And the most controversial chapter in this book, the authors state that Black people who took the IQ test they're studying scored about 15 points lower on average than white people on IQ tests on average. And that was also in terms of other IQ tests they mentioned in their research. Now, using this evidence, some people make the claim that white people tend to be more intelligent than Black people using the evidence from this book. And it was a widely distributed book. And this is kind of some of the imagery it was giving, is that Black test takers scored 15 points lower on average than white IQ test takers and in that normal curve. So let's investigate. We can't just say that. We have to actually investigate the data. In 1980, the National launched a survey of a bunch of teenagers in the nation, and they gave them the Air Force qualifying test, the AFQT. And the authors of the Bell Curve took this test as an IQ test. They interpreted it as an IQ test. You might know about the ASVAB, the Armed Services test for an entrance exam to the military. The AFQT is related to that. The authors of the Bell Curve claim in their book, the AFQT qualifies not just as an IQ test, but as one of the better IQ tests psychometrically. So they say it's a really valid test. Now, let's look at the actual test. It has 4 parts: arithmetic reasoning, word knowledge, paragraph comprehension, and mathematics knowledge. The description of each of these is given here. Here's an example question from the AFQT, a simulated question from the word knowledge section. The word solitary most nearly means, and it has 4 synonyms to that definition. You have to choose the right one. Here's a question from the math knowledge section. In the drawing below, JK, that line, is the median of the trapezoid. All the following is true except, and it has 3 statements. So here are 2 example questions from that test. And this was taken as a test of IQ, intelligence. Do you believe, this is a discussion question, based on these sample questions, that the AFQT, the test used by the authors of the Bell Curve as an IQ test, accurately measures IQ? Why or why not? That's it for today. Goodbye for now, statisticians.